So today's session, as we discussed, the objectives of today's webinar is primarily going into looking into the topics like the major 5 reasons why one has to start or one has to start learning one of the important big data technologies called as Spark, right? So that's what we are going to do as part of today's webinar session. So let me also note it down. What are the things we are going to do is, so first we'll understand why Spark, right? So what is the need of using a big data technology called Spark? Considering even though we have something called Hadoop, right? Even Hadoop is existing in the market for a long period of time, and why all of a sudden a technology called Spark is becoming an extremely important in the big data world, right? Then we can come back and understand what is Spark is all about. Then we can also go ahead and look into some of the examples like Spark word count kind of an example. Then we can probably go ahead and look into another set of things, so for instance, Spark cluster and also executing the code, executing the program in Spark cluster, right? And also we can finally come back and look into the things like what are the other main features of Spark, what are the features of Spark, and finally we can finish the course by looking into the course details from Edureka and rest of the other questions regarding the course. So that's what we are going to be discussing as part of today's webinar. So these are the primary topics of taking into this. So before even jumping into the understanding what is Spark, so one important thing I like to bring it up as part of the webinar is whatever the things we are going to discuss today, it may be the presentation or it may be the examples, everything will be available to your mail ID, right? And at any point of time, for any queries, you can contact our support team. So this is our email ID of the support team. It may be anything regarding the course or regarding any aspect. You can please contact the support team at any point of time. Yeah. So all set. So let's go back and let's jump into today's basically why Spark, etc. All those kind of things. Okay. So now, meanwhile, you can keep posting your questions in the chat window. So maybe I will take an diagrammatic an approach. So where you can easily understand the need of a Spark. So let me open up an tool called as a Glyphy, which I will technically use a lot during the course and sessions. So let me take that tool. Okay, so the tool has been loaded. So let's go back and let's start looking into this. Now, one of the most successful element in the big data world, we can primarily call something called as an Hadoop, right? So Hadoop is one of the first, probably we can say, delivered a parallel distribution kind of a solution, right? But the problem with Hadoop is a distributed file system, but which involves a lot of disk operations. So which it makes typically suitable for a batch oriented kind of an application. Okay, that's how basically Hadoop works. So for an instance, Hadoop works one of the most important algorithm called as a MapReduce, which primarily responsibility is basically whenever we talk on the algorithm called as a MapReduce, which which is the most fundamental building blocks of Hadoop, right? So this particular MapReduce algorithm, so basically what it does is that it splits the given task into multiple mappers, right? So you can say like it creates multiple mappers. You can consider if you don't know MapReduce process, that's fine. You can consider something like multiple process. A job is split into multiple process and all those kind of things. So now basically what happens, when you're trying to transform the output from one step to another step, okay? So what happens in Hadoop is, so let's consider the job has been started and the job has been split into 4 steps or 4 mappers or 4 process, okay? If you're able to understand MapReduce, you will understand what mappers is all about. If you're new to Hadoop also, so probably you can understand like it has been split into 4 different processes. The moment the job has been split into 4 different processes, the output of these processes should be carried for further level of operation, right? So each and every output should be carried for a further level of operations. Now the problem what happens with Hadoop is when you are trying to carry the output of the first step into next step, it won't go directly. In the sense, the output of all individual process will be written to the disk, right? They all will be written to the disk, and this guy will be start reading from the disk. Okay, so because of this particular important aspect of Hadoop system, it is a very good batch oriented kind of system, but unfortunately we can't use for a real-time kind of scenario. When I say real-time kind of scenario, for example, a Twitter kind of an application where the tweets are keep coming on and I need to count for an example, let's consider what is the most number of tweets. I want to do examples like that. So those kind of things and all I am not able to do. Or let's consider stock market. The stock market is again a real-time scenario where you have to basically calculate what is the total number of shares has been bought, etc. All those kind of things. So we need a solution. Big data provided a solution with Hadoop as a batch-oriented system. So whenever a particular problem is given, the problem will be given some allotment of time. For an example, let's consider generating the patient reports. You will get some sufficient amount of time. Okay, you can start up your process. The process will be keep running on and it generates some amount of reports. But there are a lot of other things which has to happen in a real-time aspect. So when you say real-time aspect, everything has to happen on the fly. So as the data is keep coming on, we need to do analysis. So this is where technically Spark started coming up in the picture. So the reason of why Spark came up in the picture is to do the same big data parallel processing system, but in real time. We don't want to do in a batching perspective. We want to do in a real-time perspective. How can we achieve this, right? So technically what Spark suggests you to tell is with a single change, with a split of a change. So what Spark is trying to tell you is that instead of writing and reading the data from the disk, let's replace this particular disk with memory, right? So when you replace this particular disk with memory, so what basically going to happen is this is going to be extremely faster compared to reading from the disk, right? It's a known factor. So when you read from the basically something from the disk as compared to reading from the memory, it's going to be absolutely 100 times faster or 200 times faster, right? So we don't know how much times faster it is going to be, right? So that is where Spark stepped in. So Spark, as opposed to Hadoop, the primary difference what Spark is trying to tell is that I'm going to follow the footsteps of what Hadoop is telling, right? So Hadoop is distributed cluster, or distributed, you can say distributed cluster, but Spark is going to add only one important keyword along with the Hadoop definition, something called as in-memory computing distributed cluster. So it is basically extending the MapReduce whichever Hadoop has stored, but goes one step further by doing everything in memory. So the point whenever it tries to do something in memory, so basically what happens is it becomes an extremely faster. Okay, when we say faster in the sense you can, we can even compare with Hadoop, it will be like 100 times faster. So this is how basically Spark won, right? So the Spark has been targeted towards the real-time scenario. Then slowly as the Spark stepped up, lot of other features started coming with the Spark. So Spark SQL, for example. So they started looking at making things faster. Hive, for example, Hive is coming from again in the Hadoop standards. So what it basically does is that again Hive it's a MapReduce job, and Hive is again going to be slower because the MapReduce is having its own issue of reading and writing to the disk. So what Spark started suggesting is, so let's come up with something called Spark SQL. Fine, it again goes back. So this is where basically Spark stepped up. Next, then as Spark become Apache top level project, okay, and actually Spark is the one which quickly reached Apache top level project. When it's Apache top level project, it's really a very big achievement, right? So now Spark is instead of supporting this MapReduce, now Spark is supporting something called Spark SQL, Spark GraphX, Spark streaming, like lot of different things has been come up on top of Spark today. Lot of different elements. Spark support for R. So every single thing has started completely coming into Spark. Then Spark ML, machine language for Spark, right? So this is countable. This is now the list will go like anything, right? So here the question will be definitely will come. One of the most critical questions will come for anybody is if data is going to be distributed in memory, what happens, right? If the memory is not able to fit the data, or if the memory is exceeding, right? So all those questions is going to come up in the picture. So basically, what Spark says, if the particular data is not able to fill up in the memory, there is something called as spillover. Means whatever the data it cannot be loaded into the memory. So what Spark will do is that rest of the data it will put into the disk, and again it will load back into the memory. So what it guarantees is that, so Spark guarantees something called as, another critical feature of Spark is called as resilient distributed data set, which means if the data set is created using Spark, it is the most highly resilient compared to anything else. Okay, this is one of the critical statement from Spark side. I'll explain you why it is called as a resilient distributed data set. It is highly resilient compared to the Hadoop, etc. A lot of other things. One of the main reason of Spark is highly resilient is because the data set how the Spark is going to get created can can retract from itself. Okay, I will explain that in detail. I'll basically explain that in very much in detail after doing some 2-3 examples in Spark. But this is what primarily Spark is targeted towards, a complete in-memory computing distributed system, right? Which will handle the typical big data scenarios of everything which can be done with Hadoop. And on top of that, it can do a lot of wide variety of things. As I said, Spark SQL, Spark GraphX, Spark Streaming, etc. All those kind of things. Okay. So this is why Spark won. Okay. So can you give some example which business line Spark is more relevant compared to Hadoop? Hadoop cannot do real time, Rishikesh. That's all. Hadoop can do only batch stop. Hadoop cannot do Twitter analysis. Hadoop cannot do any real time. So for example, let's say we want user to tweets and we need to do analysis on top of the tweets. Maybe an election campaign. We need to find who got the most number of tweets. Hadoop can't do, right? So Twitter analysis is an example, and connecting with very high speed messaging systems like Kafka, where the messages will come with an extremely high throughput. When I say an high throughput, for example, you can consider the message will flow like in 1 second you can get some millions of messages. Hadoop can't handle it, right? And likewise, so all the real-time aspects you cannot do with Hadoop, where Spark can do it. Any real-time kind of scenarios, which is like which is coming in a very high throughput, extreme faster analysis. You have to do an analysis on the fly. Typically, Hadoop is suitable for all the use cases where you will get some amount of time, and Spark is completely targeted towards the use cases where you basically can do analysis as the data is keep coming down. Okay, that's the primary difference between Spark and Hadoop. Now today, because Spark has grown to a very major kind of system, right? You can see Spark widely used even in all Hadoop scenarios also. You can say, means that's what happening now. Even whatever the job is done by Hadoop, it started getting replaced by Spark to an extent. Okay, so that is what the primary reason of coming into the Spark, right? So these are the, so when we come back and look into this, the main reasons of why we need to use Spark is, so low latency is going to be extremely faster, streaming support, data like Twitter, Kafka will be supported with on par, means as the data is coming from Twitter, it will get supported, or Kafka, right? And data from API is something of, it's actually basically coming from R, which makes your life extremely easier, okay, to work with SQL, right? And Spark integration with Hadoop. Spark can be easily integrated with Hadoop. I will show an example of how easily Spark can be integrated, okay? And overall architecture of looking into the Spark, as of now, the current version of Spark is 1.5. So the building blocks of the Spark is Spark Core. As I said, as each and every release of Spark coming on, lot of new things has been added. So on top of Spark Core, we have Spark SQL now, Spark S Streaming, the mlibs, the machine libraries, right? The graphics, which can support the Graph API, and the data frames, which is primarily targeted towards your Spark SQL, right? Which is basically which makes your life a lot easier. So let's open up and let's do a small, maybe a small example with Spark, and then we can come back and basically look into the other things. So what I'm basically going to do is I'm going to start the Spark cluster, okay, and let's first do a small example with Spark to understand how much speed it is, okay. So Spark requires special hardware requirements. Special hardware requirements in the sense, what special will be required? We need only better RAM. That's all. In all bigger systems will work with commodity hardware. Yeah, getting a RAM is not a special, right? Getting RAM is not costly, right? In the sense, it's not a special requirement. Trying to say, you can get 32 gig RAM machines very much easily these days, right? So there's no special means when we whatever the machine is available with the same machine, we might require a better RAM with Spark. Okay. So for example, you might require a 64 gig RAM and etc. All those kind of things. Apart from that, there is no other any other special requirements is required. So this is basically I have downloaded the Spark cluster. Okay. So let me go and see where we can get the Spark, right? So let me go up to the location where we can get Spark, and but how about terabytes of data can be stored in RAM? Yogesh, it's not about terabytes of data we are going to store in RAM. So the big data systems always works on a concept of we will never store the full file. We will always split the file into multiple smaller files. Even in Hadoop also we will never store full 100 TB in one shot. What Hadoop is trying to say, if you give 100 TB, the 100 TB will be broken into smaller 128 MB blocks. That's how big data works. We'll always store data parallelly across the system. So that's not a constraint, right? So if you're giving some if you give some 600 TB of data to Hadoop, it won't store in one shot. What it will try to do is that it will split the 600 TB into smaller files of 128 MB. Okay, the same thing Spark does. It's again going to split into smaller size how it can fit into the RAM. Okay. So how Spark decides what to keep in memory. So basically what happens, so the thing is, I think these questions are coming up, maybe if you guys understood MapReduce, these questions won't come up. But anyway, I will explain that, then maybe I will go back to the diagram again. So let's say when the user is passing a data, means it is nothing, it is going to work in the same way how Hadoop MapReduce is going to work. There is no special change actually. So when the user is, let's say you are, let's forward about user. Let's say we are taking the data from Hadoop itself. So let's say we are taking the data from Hadoop, and the file, we are taking a file, and let's say the file is of size some 500 MB for an instance. So the moment this particular file is given to the Spark cluster, so what Spark cluster will do, it's having two things called as driver and worker. So it will have a driver component and it will have a worker component. You can have any number of workers you want. So these are called as workers and that is called as drivers. This is a worker and this is a worker. Each and everything are different machines. So the moment you can have different workers, so basically what's going to happen is that the data of 500 MB will be split into across the memories of all the workers. It will split equally. For example, 500 divided by 3. How much the memory can load, that much it will split. And rest the driver will keep it up. Again, the data will be loaded into memory, right? So the same way how Hadoop MapReduce works. So on that point of time, how much can be loaded into the three systems memory, that much amount of data will be loaded, and we'll do the data analysis. We'll write the output. Again, we'll load the rest of the data. So that's how it's split up, right? A very typical big data kind of a system. Okay. So it's nothing like any major concept, like it follows a traditional MapReduce program. So just change hard disk to memory. Yeah. Apart from that, it will add a lot of other features like an RDD, which I'll be explaining now. Means apart from not only changing to memory, there's something called as an RDD, which we'll explain. So let's go back and let's start the Spark cluster. So just we will go to the location where you can download the Spark, right? So when you try to download the Spark, so let me go to the website of where Spark is available. The first thing is let's go and let's see get Spark. Uh, let's open up the Spark download page, which is clearly going to tell us Spark is an open source, so one can download and start working with Spark. So you have to only come up with your clusters, right? And Spark comes with inbuilt support for Hadoop. So you can primarily look back into see there are different Hadoop versions available. So that itself says, so Spark is basically will be supported by multiple Hadoop versions. And adding to this, Spark is also one of the important things you have to understand is Spark can work with or without Hadoop. Okay. In the sense, what I am trying to say is that if the data is in the Hadoop file system, Spark steals the data from the Hadoop file system. Otherwise, fine. The Spark is basically going to be taking the data from the other systems also. It's not mandatorily it should be from Hadoop. Okay. The memory can be an SSD or no, you typical RAM, Shiva. Your memory requirement 64 gig. You are having a 16 gig RAM, right? The place of 16 gig RAM, you should have 64 gig RAM. That's all. It's nothing less. Typical memory how you are splitting into your system. Okay, so the moment you're downloading Spark from this particular location, so basically one can come up. So this is where the Spark means available. So I'm going to start the Spark cluster. Okay, so ls. So let's start the Spark cluster. So Spark is completely built on one of the most successful languages which is existing in the market today, Scala. The Scala is one of the most functional language which is being using very widely these days, right? Even in fact, the Kafka also is developed on top of Scala, and lot of other technologies has been developed completely on top of Scala these days, right? So whenever you open up the Spark, so it will show you up very clearly which version of Spark is going to install. You need to install Spark if you want to use Spark car. Everything will come as part of a package, Pavik. The Spark cluster will have everything as its own package. There is no need to install any other thing apart from that. What is R signification in Spark? So all the statistical analysis we can start doing R for 100 TBs of data with the help of Spark. Actually, I am not comfortable. No, Pavik. The complete Edureka course will be doing with a new language called Scala. The course will first explain you the Scala. There is no Java involved as part of the course. We will do with Scala. Okay, so now the moment the Spark shell comes up, so what we are basically going to do is that, as I very clearly told, Spark, how it works, the moment you tell the data, I don't know how the data is going to say. Either you tell the data is coming from a Hadoop file system, or let's say you can say the data is coming from a local file system. It never cares, right? Or the local file system, or you can even go back and say data is coming from a Cassandra or you can see data can come from Kafka. It can have wide range of options. There's no such restrictions. Now let's start the loading the data from the local file system. Okay, I'm going to load the data from the local file system and I'm going to do some operation to see how much faster Spark is going to be, right? So let's if you, first it's a Scala, as I said, REPL. So Scala is a very powerful languages. So whatever you execute, Scala will execute just like that. On top of that, will provide you the result. Unlike other languages like Java and all, where you have to compile and execute, Scala will be doing everything on the fly. Okay, so no need to worry about that. So what we are basically going to do is that we are going to load the file. Let's first of all go to the location where Spark is installed. It's not an installation, it's just an extraction of the zip file. A very straightforward Spark, there's nothing else involved. So one come back and see into the Spark corresponding location and let's take a particular file. Let's take this file. Okay, I'm just taking this file and this file is basically having I don't know what is the size of the file. Let's say at least a good amount of file. So let me see what's the total number of lines available in this file. I think a huge file, right? So probably the total number of lines is it coming somewhere. If I say total number of lines, I think probably it's coming under 25,116. It's a good amount of lines. As we are doing from a VM, it's a decent amount of file. In this total file, I want to count whatever the lines coming with A and whatever the lines coming with B. I want to calculate that. If I do the same thing with MapReduce, with the Hadoop, I'm pretty sure it's going to take a lot of time. First of all, I have to develop the Java code, then I have to take a jar, then I have to submit to the Hadoop file system, which will end up in at least will take some 5 minutes of time, 5 to 10 minutes of time for me. Let's try to do the same with Spark. Let's see how much fast everything is going to happen. So this is the location where we are going to have the file, right? So the changes.txt. So this is the location where the file is available. So we are going to load this file and we are going to write some Scala code and we are going to execute in Spark. Let's see all the actions what we are going to do. Let's see how much amount of time it's going to take, right? So the code which I am going to write, you may not understand because you need Scala knowledge, but as I said in the course, we are covering the Scala first. So one never needs to worry about that particular aspect, right? So first thing what we are going to do is that we are going to load the file, fine. So after loading the file and basically we are going to write some code to find how many times the letter A has come. That's what we are going to do, okay? So let me go back and let's maximize the console so that it will be easier for everybody. Okay. So let's see the sequence of actions. Let's take the time. Let's see how much faster we can do this. So let me clear the console. Can we install? No, you can install Spark in Windows also, Bhavik, but mostly it will work only the Linux environment. Okay. So first we are going to load the file. Okay. Let me load the file. So I just loaded this file. Okay, I just type the code, means little bit of drag here and there will be there, but let's see. So what we told is that to the Spark we told this is the file which we are going to work with. You can clearly see we told something called file colon triple slash. In the sense it says the file is picked up from the local file system. Okay. The next thing what we are going to do is that we are going to load this particular file into how Spark can understand. So what we are going to do, we are convert this particular file into the way how Spark can understand. This is called as an RDD, means the data set in Spark are called as resilient distributed data set. Okay, means which is maybe after this example I will explain you what is that. Okay, what's the difference between Scala and Spark? There is no difference. Spark is a framework which is developed using a language called Scala. Fine, nothing. Scala is a language, Spark is a framework. Spark developed using Scala. Like Hadoop developed using Java, Spark developed using Scala. Scala is a language which has been used to develop Spark. Fine, Arjun? Yeah, so CLI command is something, Jair, you can't understand because it requires Scala knowledge. So you need to understand the scalar knowledge. As it is only 1 hour of session, we can't go and discuss on the scalar. Once you join the course, we'll be explaining you what scalar does. Okay. So here what we are trying to see, how much faster Spark is going to be on counting the number of lines. Fine, Jar. That's what our intention, because code is something which you can understand only with this. Okay. Can we use R language instead of Scala? Yes, you can use Sanil Kumar. In fact, the course says that also. So now I'm going to basically execute a job which we are going to say count the total number of lines. Okay. So you can see now I'm going to execute a job. I'm telling from the given data set count the total number of lines. Now let's see how much time it is taking. I'm going to enter now. Let's see in how much time it is going to finish this. It's running and it has finished the job, right? It has finished the job in 1.81573 seconds. This in any case in Hadoop will take 1 minute of time, at least 2 minutes of time. So the total number of lines available is 14,453. So out of 25,000 lines, we wrote a job with the help of Scala, which says technically out of 25,000 lines, 14,450 lines, we are having the line which is having A, right? So this shows how much faster it is compared to working with Hadoop. The primary reason is here technically what happened is it has been executed with the help of your in-memory computing system, right? So that's why Spark is extremely popular to use, and that's why Spark is one of the best frameworks which is existing in the market today to use. Right? One of the best frameworks which is existing in the market. Okay, so now this Spark can be developed with wide languages. Scala is not a mandatory tool. Okay, so when you look back, and I will show you something. So when you look back into our slides, you can see the languages with which this Spark can be taken. Okay, approximately how much time takes Hadoop instead? Hadoop will take easily 1 to 2 minutes per week. The Spark did in 1 second. So this same amount of code what we wrote in Scala, we can do with Java, we can do with Python, we can do with R language. As of now, you can do with all the 4 languages with help of your Spark, right? You can do with Scala, you can do with Java, you can do with Python, and you can do with Java R language too. Okay. Where is the result of no, here the result of computation is not stored because I have taken the file from the local file system. Okay. So now let's say you want to load the same file from HDFS. So what I'm going to do is that let's go back and is there any performance impact? No, definitely not, Shivan. There is no performance impact and all. It will be exactly same. It's your comfortable level of using which language. But the complete framework has been built in top of your what is it? A complete overall framework has been built in top of your Scala language. Okay. So now the same file is going to be available in HDFS. Okay. Now we actually loaded the file from the local file system. So what we are basically going to do is that, and the same file I have put in the HDFS. So the only difference is going to be, right? So in the place of, let's say, in the place of we are loading something called as, let's go back to the Scala shell and let me go back to the Scala shell. So in the place of file colon triple slash whatever we have, right? So if you are not giving this file colon triple slash, okay, and if we give only the path of the file, so let's say let's give only the path of the file, means now the file will be loaded from HDFS because by default Spark has been developed to work with Hadoop, right? So now let's see how much faster it's going to take. The same amount of operation I'm going to do. I'm going to load the data from HDFS, okay, and convert the file into the way how Spark can understand. The same way how we did before example, the same way we are going to do here. Okay, so that the conversion of the data into HDFS or conversion After loading the file, the conversion of data is something which we'll call as, we'll technically call as the RDD, which is nothing called as a resilient distributed data set. Okay, and I will give a glimpse on what is an RDD now. So now we loaded the data from HDFS. Let's again do a count. Again, we are going to do a count of the operation what we did. There's nothing special new thing we are going to do. Let's enter. Let's say how much time it is going to take. Now we are loading the data from HDFS and dumping the data into the Spark cluster and trying to get the output. Previously, we are trying to do only one operation, something called as typically executing the output from the what to say, from the local file system. Now the same set of operations we are trying to do by doing from the loading from the Hadoop, and we are trying to do. Okay, so the moment I'm going to press enter now, it's going to take some amount of time, and let's see what is the amount of time it has taken. So the total amount of time to taken to execute this particular job from Spark is 581 milliseconds. If you compare at any point, Hadoop cannot do with this performance. Hadoop will be far less compared performance compared to this. So that's the beauty of working with your framework called as Spark. Okay. That's one of the most as one of the most important critical things of the Spark, where you can technically go back and see that it's going to be extremely faster compared to your programming language, something called as an Hadoop, where it will definitely take more number of time, right? So that is why Spark is a very famous system. So regarding the data in the memory, there is no issues. There is something called spillover, where the data which is existing, or if the data is not able to adapt in the memory, it will spill over the data, rest of the data to the disk, right? That's another important feature of Spark. Okay. So that is one of the main reasons of using Spark. And as I said, there are a lot of other things also involved in the usage of Spark, like Spark SQL, GraphX, and etc. All the other important APIs also which has come up these days. Okay. So far clear, everybody? Can I get a quick yes from you all? You are getting a point of why we require Spark and what's important. As I said, this is a webinar, and the main intention of this webinar is to just to show you how Spark can be used effectively compared to Hadoop, how much it's performing better. And while you join the course, right, we'll go in full-fledged detail of understanding things like what is RDD of Spark, how RDD of Spark works, what is Scala, how to do Spark with R, how to do Spark with the rest of the other components, all those kind of things. Okay. So that is what, Manoj, I was trying to give an answer. If the data which is exceeding the memory size, Spark is having a spillover concept where the excess data can be spilled over to the disk, right? And again, it can be put back to the memory again. Fine, Manoj? That's a spillover. It will safely spill over the data which is not able to fit into the memory. Okay? Fine, Manoj? So there is no problem happens. Yeah. Can we configure the amount of data? No, why you want to configure, Sakshi? That's if you should never configure. That's called parallel systems, right? You should tell the parallel systems. So if you want to configure the amount of workers, so in the real world system there will be 5,000 workers. Can you go and control all the 5,000 workers? Is it possible for you to control? So which is the better way? Framework take caring or we? So framework has to take care. We have to tell the framework what is the size of the input file. From there, it's framework responsible to take care of how to drive from there. Okay. What is the role of Spark in data analytics area? So today Spark is playing 99% of all the use cases in data analytics. Whatever the data analytics, a batch job, okay, taking an 100 TB of file and generating the report, fine, and all the exactly similar. You guys, can you able to hear me? Sorry about that. Can you guys able to hear me, everybody? Yeah, can you able to hear me now? Can you guys able to hear me? Hello? Can you guys able to hear me now? Everybody? Yeah, fine. Sorry about that. I just okay, fine. Yeah, I just reconnected it. I'm sorry about that. Okay, so this is what basically one of the fundamental things of using the Spark actually. You guys are able to hear me now, right? Everybody? Hello? Okay, yeah. So do you have any questions on the things what we have discussed so far? Like the Spark in-memory computing system and any of you having any questions on this? Any of you have any questions on the in-memory computing systems what we discussed? So Java and Scala is similar. Okay. So yes, Java and Scala are similar. In fact, Java and Scala are both are JVM based languages. Both are developed on top of JVM. Whereas Scala is a completely functional oriented language. And if you come back to Java, and that's what the main difference. Okay. But in fact, both of them are JVM based operations. Fine. How Spark will be better than Storm? So Storm does only one side of the data analytics, but what Spark does is Storm is completely towards the real-time stream processing. Whereas Spark is something apart from real-time stream processing, it also can do the Spark SQL, Spark graphics. So a lot of other functionalities also can be used along with Spark. Whereas Storm is completely only for your real-time stream processing. So Spark can do real-time stream processing, Spark can do the graphics analysis, Spark can do a lot of other things on top of that. Okay, so that is the primary difference actually. Spark stores data in some nodes and process it in memory. No, Spark never stores data in some nodes. Spark reads the data from the external system and process the data in memory and sends the data output back to the place wherever you want. Okay, yeah. The Spark replaced Flume, Pig, and Hive. Yes, I can definitely say that, Anita. Which protocol you? That's a basic TCP protocol, Ajay. How the file system protocol will use the same protocol actually. What if the system goes down, the data at present memory gets lost? No, that's not a problem in the big data system, right? If one of the system goes down, the another system will pick up. So that is what basically happens in the case of the big data systems. If you have multiple systems, so how the big data process systems will work is, if let's say one of the data system goes down, what the driver will do, the driver will again submit the data to the another worker. So you have multiple workers, right? If it is given to worker one, right? So if the worker one goes down, you can basically go back to worker two. So that's how the basic big data fundamental system works. It will always can go back to any amount of worker, it can do it actually. So that's one of the main things of using Spark, right? Which major company is using Spark now? So probably we can say 80 to 90% of the organizations are using Spark now, right? In fact, most of the organizations have started using Spark. So if you come back into C, we have a study of basically what are the organizations are using the Spark to which greater extent. We also made a slide based on that showing you. Okay. So I will just show you a slide which is basically stating which is basically going to handle more number of it. Okay. So let me open up the slide actually. So Spark also taking 3 copies of data node in all information. No need to do that, Bhavik, because the thing why Spark doesn't need to do this particular kind of an operation is because the Spark is technically what it does is that it will submit the job to one of the worker, right? And if at any point of time, if the worker is not able to do that particular or worker is crashed, it will submit a same result to another worker, right? So Spark does the processing. It never does the data storage. It's like the map reduce, right? Hadoop, we have two things. One is called as an HDFS, one is called as a map reduce. HDFS is the data storage and map reduce is the data processing. We are trying to improve the data processing, right? So there is no need to Spark to worry on the 3 copies of data. Is the MapReduce is taking 3 copies of data? No, right? So what basically MapReduce does? So basically what MapReduce does is it takes the data, it processes the data and sends the vector data back to the storage. Same thing Spark also takes the data from HDFS, processes the data and sends the data back to the storage. The processing of the data is something what we are trying to concentrate more. Okay, fine, Bhavik. So Nikhil, to answer your question, you can probably look back into see how the organizations are primarily using it. So if you look back into see 82% of the organizations have started using the core API and etc. all those kind of things, correct? So this is what basically happens. Is it useful to learn MapReduce since it seems everyone is switching to Spark? If you want to start the career freshly, what I will suggest is you can come back and directly start working into the Spark. Hey guys, can you able to hear me now? Here. Yeah, yes. Thank you. Okay, yeah, fine. Yeah, yes, sure. So RDD, so maybe I can give a very small note on RDD, not maybe a briefer explanation because the briefer explanation of RDD which will basically give you once you join out the course. So, but basically what I can tell is that RDD is something called as a resilient distributed data set. Okay, so a resilient distributed data set is called as an RDD. So what basically Spark does is that, okay, so Spark basically what it does is whenever the data has been loaded, right, it draws a graph of environment. So for an instance, let's consider, let us go back to the Glyphy. So if you come back to the Glyphy, so basically what happens is, let's say I want to do a series of operation, right? So if I want to do a series of operation, right? So let's say I have multiple stages in the operation. The first stage is basically, let's say load data from F5. Okay, the first step of operation, what I'm trying to tell is that load data from a particular file. And the second set of operation, what I'm basically going to tell is, after loading the data from the file, the second set of operation what we are basically going to tell is filter data without spaces, right? The second set of operation we will say, and the third set of operation what we'll basically go back and say is that let's come back and let's draw one more set of an operation by telling something called as let's say filter data having only letters A. This is the third set of data, only having letters, particular matching letters. Now the fourth set of data set is going to come back and say count the letters, right? So we can have four set of operations. Maybe in the graph, let's say the final operation is basically coming back and telling something called count the letters. So if this is a sequence of operation, what Spark will do compared to other things, right? Spark will first draw a graph. This is called as a DAG, called as directed acyclic graph, right? A directed acyclic graph is something called as, the first thing what Spark will do something called as a DAG. This is called as, I'll write it down, what is the name of it? So that this directed, even before doing any job, The first immediate thing what Spark will do is it will draw a diagram, draw a logical flow called as directed assembly graph. Now what happens is this particular graph will be sent to the workers, right? All the workers, let's say you have three workers. Let's say worker one, you have all the workers. Worker one and worker two and worker three. Let's say you have all the workers. Worker one, worker two and worker three. So basically you have three workers. So what the driver will do in the case of our Spark context, the driver is basically means you can have any number of workers. It doesn't matter you should have only three workers. You can have any number of workers. Okay. So now basically all these are typically end of the day are machines. Or the workers or drivers are basically a simple machines. Okay. And what basically will happen is the driver will basically send the graph to all the workers. Right. So now basically what happens is since the graph has gone to all the workers, now basically what happens, let's say worker one is start doing a particular processing. Okay, I just take out this particular line. Now what Spark will do is that it does, let's say worker one has started his work and worker one has finished three steps. While doing the fourth step, the data is lost. So what it can do is that it can retract itself from the graph. Instead of doing everything from the scratch, it can go to the third stage and do the operation from the third stage. Let's say something went wrong in the third stage. It can go to the second stage and get the data from the second stage and start doing that. Similarly, let's say if complete thing itself is gone, not a problem. The worker knows the graph. It again can redo from the scratch. That's why Spark is called as this RDD, Resilient Distributed Data Set, where it can retract itself from the series of operation what it is going to do. Right? That's how Spark is highly smarter compared to the other things. So even before doing any amount of operation compared to an Hadoop or rest of the things, okay, that's what Spark does. Okay. As a driver and worker, the same as job tracker and task tracker. Yes, they are same as job tracker and task tracker. Multiple task trackers, one job tracker, or you can call it as resource manager and node manager. You can put it that way, right? So that's why Spark is called as highly called as an RDD, something called as an resilient distributed data set, where if at any point of time if something goes wrong, it can retract itself from that point of time. So that is what the basically Spark is very highly powerfully used. There is no need of starting everything from the scratch again. So just think about in a real-time scenario, if you have 20 steps, that's how it will happen. If you have 20 steps, what Spark will tell is that if 18th step has gone down, no need to redo from the scratch. I can retract myself from the 17th step. Similarly, if 8th step goes down, I can go back to the 7th step and start from there. If everything gone down, no need to worry about because we have the graph, we can resubmit the graph again and that guy will redo from the scratch. Okay, so that's what basically the Spark is all about. That's why the Spark is something called as an RDT. Each and every stage, the data in the Spark will be loaded and it will be remembered as part of the sequence of an operations. So that's why they are called as an resilient distributed data set. Okay, is it understanding everybody? What is a resilient distributed data set? You guys are clear on what is an RDT, right? So that's the power of basically, that's why Spark is one of the most highly resilient distributed data set, right? That's why we are trying to sell. So Spark is lightly loaded, unlike your Hadoop or other systems where you have to again resubmit the job from the scratch. Spark won't do that. Spark will draw the graph, directed acyclic graph, it will give to the workers. If something wrong happens within the worker, there is no need to restart from the scratch. It knows itself where to track. Let's say worker itself gone down. Okay, everybody. Actually, so I think we can't means that we discuss the most important core features of Spark, like RDD, etc. And probably we can basically do a lot of other things also. It means we can discuss a lot of other features of Spark, etc., which basically in the sense will take a longer time to discuss, and we have only 1 hour of session, right, which probably we can't discuss technically more actually. Okay, so coming back to the courses and what are the things available as part of the course when you join this particular course, right? So you can basically, let me take the slide of the course details. So this is where the course details is all about. You can go to this particular link and you can get back the information about the course, right? You can also contact the support regarding the course details and etc. all the other things, right? So when you join as part of the course, we'll be discussing very much in detail of the other things like how to execute the same. For example, as part of the course, we'll go to in very much detail of understanding each and every elements of the Spark or Spark data frames, and also the machine learning, how to use machine learning with Spark, etc. All those kind of things. Okay, so today's session, we primarily want to look into something like how much Spark is effectively faster compared to Hadoop, and how the in-memory computing system works. But when you join as part of the course, right, you'll get a lot of other important details like the Spark in-depth architecture and etc. A lot of other things. Any other questions from anybody still? Can I get a quick can a person with basic Java knowledge understand Scala? Definitely, Yogesh. Yes, yes, yes is the answer for it. Can join the course and understand the course. Can I get a quick yes from you all? I hope everybody followed, right? I know some audio glitches happened here and there, but you all got the objective, right? Sorry about that. I was just technically switching on between the things. Yeah, thank you. Sorry about the audio glitches. I was not sure how happened. Okay. SQL background, good question, Umesh. So means Spark SQL will be quite different compared to traditional SQL. We have data frames. Data frame is an API, again coming from Scala and the R background, which makes your life lot easier. It's like accessing your POJO elements with help of the Spark SQL kind of thing. It's a basic SQL only, but the way it is going to be accessed is going to be quite different with help of an API call as a data frame. Where again, when you join the course, we'll be explaining in detail. But as what technically I will suggest is, as a prerequisite for joining this course, right? It's not mandatory to have Hadoop knowledge. Please keep in mind that. Okay. First of all, three things please keep in mind. It's not mandatory to know Hadoop. It's not mandatory to know Java. Okay. We will teach you Scala. We will teach you Spark. Right. If you have experience in Hadoop and Storm and Kafka, it is good. But it's not mandatory to know Java. It's not mandatory to know Hadoop. Okay. In fact, Spark itself is a very wide range. Okay. So please keep this something clearly in mind. There is no such prerequisite. You must know Hadoop. There's nothing like that. We can go everything from the scratch again because Spark is something can work with or without Hadoop. That is something please keep in mind. If you have the advantage Spark Hadoop knowledge, it's fine. That's not a problem. Okay. That Spark support data transfer. Yes, yes, definitely, Nandita. It supports. That's why Spark SQL is there, right? It will do. Scala is mandatory to know for Spark. It's not mandatory, Sula, but as I said, as part of the course, we'll be explaining the Scala also. So you don't need to worry about that, right? The reason of we are emphasizing the Scala more and more because the language itself has been developed with Scala, right? So that's the only main reason. But adding to that, you can also do with the PHP and etc. A lot of other things also. Okay. So these are the features which you will be learning as part of the course, and also you can come back and basically there is one more batch is going to start very quickly. Okay. Generally, big data itself is not suitable for OLTP size. Big data is for OLAP, analytical process. It's not only about Spark. Technically, big data it's not towards the online transaction process. So you can look back into this. There is a batch which is big data batch which is technically starting on the 26th. Okay. Okay, so I can means basically if you want to still go back and look into more details also, I can basically open up the course too. So let me, you guys also can meanwhile open up the course. I can show you on. So this is the page which I'm going to open now, which primarily going to explain in detail of all the courses. I'm also pinged you guys. You can click into that where you can basically go on and go into full-fledged details of all those things, which will be explaining you what are the things we are going to cover, etc. All those kind of things. Spark SQL will be similar to MongoDB SQL. No, Yogesh, MongoDB is no SQL. This is SQL, right? MongoDB is no SQL, and here we are talking about SQL. Spark SQL will be similar to SQL language. Okay, fine, Yogesh. MongoDB is no SQL, right? Here we are talking about the traditional SQL language, how you can execute over the big data applications. Yeah, fine, Yogesh. So here it is basically pointing towards the traditional SQL. Okay. So you can please go over the course details, everything into this. As I said, when you join as part of the course, we'll go in full-fledged detail of understanding different aspects of the course, why this course is required, etc. All those kind of things, right? So it's a duration of the course is basically it's a 4-week course. If you're taking as a weekend, and weekday is going to be 4 hours of course, and you can basically go on it. Okay. Can we use NoSQL with Spark? Yes, you can use NoSQL with Spark. HBase is NoSQL. We can use HBase with Spark. Fine, Sulu. We can use HBase with Spark. We can use Phoenix with Spark, all those kind of things. So these are the complete set of things you will be understanding as part of the course also, right? So basically the course will be something like this. It will first explain you the Scala language, going in detail of understanding that what are the uses of Scala, etc. Then we'll go back and all those kind of things. Will you teach how to configure Spark with that? There is nothing like how to configure Shobit. You can open the Spark cluster and start executing the R code. So that also will be executing as part of the course. As part of the course, we'll be also going and explaining you how to execute the R code with Spark. Fine, Shobit. Okay, so fine everybody, to summarize, I'll just give a quick note. So Spark is an in-memory computing system which typically can again handle huge amount of big data, right? So it's going to be completely in memory, and it can be used with Hadoop, it can be used with other systems also. So it is typically targeted towards the real-time processing systems and having a lot of other features like Spark SQL, Spark R, etc. All those kind of things, right? So the moment you join the course, you will basically get more and more details about the course and etc. rest of the things. So please look into the course and also get in touch with the support team for rest of the details. And also you can contact me at any point of time. Okay. At the end of the course, we'll also provide you a certificate. We'll provide a use case and also a certificate, which will make sure you are technically having much more knowledge with Spark. Okay. I hope you all enjoyed the session. Sorry for little bit of glitches in the audio happened here and there, but I'm pretty sure everybody followed the examples and how the RDD works, etc. As it's a very 1 hour of session, I am not able to cover everything in detail. The moment you join the course, I'll be going everything in full-fledged detail. Okay. Thank you, everybody. I think it was a very good webinar. Please contact the support on the same, and they'll help you in everything. Okay. Thanks, Shobit. Please kindly fill the feedback. I really apologize for small glitches happened here and there in the audio. And thank you very much for joining the webinar, everybody.